Let's consider placement of various objects at geographic coordinates. We're going to place several GSM towers from the georeference terrain generation asset pack. Add a new points object. Let's name it towers. We need to specify an asset containing vector points with georeference. Usually it is a shapefile. Other formats are also supported. The complete list is available in Sandworm documentation and on the GDAW website. You can use web resources like bb.org, which provide open vector geodata in various formats. The asset pack includes such a file called Unique Buildings. Click Preview to see its contents on the map. Adjust layer boundaries if you want to use only a subset of points. You can also apply filters based on the attribute data available in the file. Click Add to add a filter and configure it based on the value of the selected attribute. The file we use is a small part of a vector database, so there are only 30 points available here having a single attribute with the same value, so filtering by value is not really helpful. Your sources may have a completely different set of data, and filtering will enable you to select only the necessary objects. We'll look at filtering in more detail a bit later. Vector data can also be obtained from tile map services. You can add a TMS data source. Similar to raster ones, vector TMSs provide data in the world map cell specified but as vector geometry. If an error occurs or the selected TMS source does not provide supported data, you will see an error message with details of the problem in the console window. Let's specify an asset with the tower model in the node field and configure the following generation parameters. Use as fence. Enable this option if you want to place models along curves, typically to generate fences. In our case, we keep this option unchecked. Collider implies creation of collision shapes for objects that are intended to take part in physical simulations. Turn it on if generated objects should be used in physical simulations as static colliders. Drop to ground. This option is enabled by default so that the lowest point of each generated object is aligned with the terrain surface. You can increase the height offset value in case objects are partially under the ground or too high above it. It is worth keeping the bake to cluster flag on that the target object is represented by a static mesh, like in this case. This will make all cloned objects baked into a mesh cluster object to optimize rendering and improve performance. You can also specify the front axis of the object for correct horizontal orientation. Let's create the object and generate the result, making sure that only vector object generation is enabled because terrain is already there. After that, we get GSM towers placed at the specified coordinates. Next, let's look at generating roads along curves. For that, you need to set up a section of road with the prepared material and textures. You can use the ready-to-use model from the road folder as an example. The plane should be oriented horizontally and aligned along the axis. In this example, the x-axis corresponds to the front direction. Go to Sandworm and create a new roads object. Here we'll specify the road shape file from the asset pack containing vector splines for roads. The setup is similar to the creation of point objects. This asset contains a lot of splines. Let's consider filtering the data. Add a filter and click on the icon to see all available attributes assigned to the curves. Attributes are displayed horizontally. You can sort the table by clicking on the header. Rows correspond to entries having certain attribute values. In the top panel, you can select the attribute you are looking for, the value of which must satisfy the chosen condition. For example, the name must be equal to the specified value. By clicking on a cell, you can quickly set the desired attribute and value. In the drop-down in the middle, choose one of the conditions. The attribute value is equal or not equal to the value. The value is greater than or less than the value you are looking for. This is fine for numeric values. For example, we can select roads that have the index higher than a certain value, or choose any for non-empty attributes with any value. Let's select only curves having the residential value of the highway attribute. You can add multiple filters, for example, to filter out other road types, and choose a relationship between the filters, logical and, which means the filter will be applied to the result of previous filters, and logical or, which means the results of this and previous filters will be joined. Specify a node with a road segment, and set the rest of the parameters. Generated roads are baked into decals for accurate projection on the terrain surface. Select the resolution of the textures to be generated for decals. When positioning road segments along curves, the tessellation of the original mesh matters. The higher the detail, the smoother the joints and turns will be. You can also engage segment splitting by a fixed length. The default is 10 meters. This will split all curves into additional subsegments, making the shape of the road smoother. The split line's length parameter splits all roads into a grid of a fixed step. The default value is 100 kilometers and is intended to optimize performance when creating large road systems. The adjust terrain heights and masts and area width parameters are designed to flatten the terrain surface under the roads. This feature is only available for global terrain and will not affect landscape terrain. The last parameter enables you to select the front axis of the road section. In our case, it is the x-axis. After generation, the scene has several mesh decals with roads projected on the terrain surface. In some cases, road decals, since they are projected from a certain height, may affect some objects such as trees. You can prevent tree materials from being affected by road decals via adjusting the material bit mask in the material parameters. Turn off all bits in the material mask for tree materials and do the same for tree imposters. Now the vegetation will remain unaffected by the decals. You can also fine-tune the masks to filter out certain decals only. Similarly, grass can overlap roads. You can take advantage of intersection tests between objects by specifying a common bit for the cutout intersection mask of grass nodes and the intersection mask of road decals. This ensures that the grass will be cut out in the areas under the road. To learn more about the bit masking, watch the corresponding video tutorial. In addition to roads projected onto the terrain surface, we can also place objects along splines such as this section of a fence, or various communications like water pipes or electrical networks. When preparing a template model, take into account the position of the object's pivot point. Sections will be placed according to it. If you want a fence along the road, not in the middle of it, you need to shift the model to the side by half the width of the road. Create another points object, name it, and add the same vector source with roads. Nothing has changed on the map, but now there is one more layer with splines. We will place fences near some of the roads, so we'll add a particular filter for that. Let's specify an asset with a fence section in the node field and enable the use as fence flag to indicate that we want to place copies of the object along the splines. The auto-size flag enables automatic calculation of the object bounds and step between the sections. You can override the step in meters and the offset of the first and last segments from the start and end point of a single spline, respectively. The fit-to-size flag will force the segments to adjust their scale to fill the gaps between them. You should already be familiar with the rest of the parameters, so let's get to generation. You can also place billboard objects along curves to imitate city lights, for example. Create a new billboard node and adjust the material. Let's make it round and emit light. Save it as a node reference. Now use the billboard asset instead of the fence model. As a result, we have a simulation of lots of lampposts, suitable for long-range bird's-eye views. You can control the look via a single material.